Just hold on.
You would do the that and then you would times it by 4 and then that would I figured it out.
Good. Yeah.
Good job. Good for you.
See if that helps? Yeah. Now everybody's gonna start talking like.
Oh, darn it, Cherry.
So that's the way we would write it, but that has to specifically answer one of those questions. Increasing or decreasing.
So did you get it?
Why is
I can't smell anything. It's like, yeah, I saw that. What? That's you, but I need. I don't want to get new.
I mean, you did a good job trying to figure out. Are you serious? You asked me for that for medicinal purposes, and are you not able to have that flavor?
I am. But like, yeah.
Okay, yeah, it shouldn't really be about the preference of flavor if you're using it to suppress a cough, okay?
You can tell me this is right? You go over
Yeah.
it. Can you tell me that right? Better. Like, is that like?
Well, you couldn't, so.
I know it is. But like,
Yeah, it's hard to
No.
tell sometimes.
yeah, I didn't do it right.
4 times 2 is not 16.
No, because you do.
No, he's just, everything is weird about that.
Well, the way you said it.
Yeah, I don't know how to do it. Because you do -2 times 4.
Alright, I'm going to go over it. This is where we kind of left off yesterday. We talked about it a little bit, but I posed this question because, for 2 reasons. Number one, I want to kind of finish off what we started with that last example yesterday. And number 2, because half of your homework is this very same type of question. There are 4 questions on your homework. Some of you have already completed it. That's awesome. Raise your hand if you completed the homework.
I haven't even looked at it.
Okay. The people, okay. You put your hand down and you put your hand down because you did it with me. You, and you. Is there anybody else who completed their homework?
You did.
I did not.
Okay. Just out of curiosity, when you completed the homework, raise your hand if you completed the homework and got 100%. Okay. So, do you know how to do this then?
Yeah.
Oh, you do?
Yeah.
Okay, awesome. Charlotte,
Then do it.
did you complete?
I didn't do it.
Did you get 3 and 4 wrong?
I didn't got half credit because it was like 2 parts.
Okay. Okay. I was just curious because I want to know, like, if you guys completed it, like, did you understand it? Because then you would be able to understand this. Anyway, okay. So this is 2 questions on your 4-question homework. So if you haven't done it yet, you really want to pay attention. And even if you have done it yet, if you didn't totally understand it, you want to go back and fix it, you want to pay attention. The wording of this is really weird. That's why I gave some hints to describe what it's actually saying. But the reason I chose this wording is because that's how a lot of times the question will be asked, and you need to know what it's actually asking you. Over what interval? Now, even just in those 3 words, we're already confused, right? Mm-hmm. Something that I wasn't thrilled with when we started this Do Now is that you guys read the question, paused, and some of you said out loud, I don't get this. Some of you said out loud, this is too hard. None of you said, I don't really understand it, but let me look at the hints and see if that helps me. I don't really understand this, but let me try and see if I can get somewhere, and maybe I'll ask somebody. Some of you took that route, but what I heard from a lot of you is, I don't get this is too hard, this doesn't make sense. With that attitude, that is basically asking to not understand things and then consequently to fail quizzes and tests. So when you got, that's actually quite distracting when I'm trying to speak, okay? Thanks. So what I really need from you guys is to approach a question with a little bit more positive thinking, okay? It doesn't mean you have to enjoy it. It just means that when you read a question, you don't just give up on it immediately because you don't like it or you feel like it's too hard. If you want me to make the questions easier, I can, but then you'll also fail your EOC and your quizzes and tests because I can't make those questions easier. I can make my classroom questions easier if you want to feel good about yourselves. It's a choice that you have to make for yourself, okay? I don't need Chromebooks open unless you are following along with the lesson, and this is not part of lesson 7.2, so everybody eyes up here. Over what interval? Who knows what that means? We'll talk about it in a second. Is the function of x equals 4x squared increasing? Over what interval is it decreasing? So before we worry about the intervals, let's look at this function. Even if we don't really understand the question, we certainly can do the first hint. Make a table of values to see inputs and outputs. A lot of you didn't even make a table of values. Some of you tried to make a table of values and did great. Some of you tried to make a table of values and it just was totally wrong, which scares me because we have lots of tables of values in our notes. So let's do the first hint and make a table of values. A table of values needs an input column. It needs a column for the actual function, and it needs an output column. And if you put like x comma y as that column, that's totally fine as well. You can either read your coordinate pair like this, or you can put it over here. Totally fine. Can somebody please tell me what numbers I should use as my inputs? What are our go-to numbers? Yeah?
-1, 0, 1, 0.
Good. -2, -1, 0, 1, 2. That is our kind of go-to inputs that we. It what? Oh, okay. That's okay. Thank you for noticing that. Okay. So, what is the next step after I put in my inputs?
You do the thingy where like you put the inputs in where x is.
Yeah, we actually input those values. We put them in to the machine and let the machine do its function. Angus, look up, okay? And you're kind of staring down like at the floor. I want you to look up here, okay? You feeling okay? Are you okay? Okay. Okay, so we're going to input or put in a value into the machine and let it do that specific function. Now, it would be nice if we just put it in and then it does it for us, but we actually have to do some math and solve it. Please pay close attention as to how to solve this because some of you just did not even solve this function right. So 4 times -2 squared. If you didn't write this exactly like this, then you did it wrong, okay? And you are asking to get the wrong answer. This is the proper way to input the value -2 into your x spot. Now somebody tell me something really important about solving this the right way. Faith. What? The negative is in the parentheses, so that's done. Any?
You have to do the parentheses first, not the exponent.
What?
What?
You have to like multiply forward -2 before you multiply it.
What
I
are
tried
you
something
on
to throw
about?
at you right now.
What are you on about?
Oh,
Those are my
it's so heavy.
glasses. Those are my
Okay, and they're
glasses.
expensive.
Here, you can throw this in and I'll.
Oh, my So I had to throw something at Jacob because he said the actual opposite of what I was looking for. Too bad it's not opposite day.
Oh,
Well, it would be positive since it's squared, right?
gotta do PEMDAS.
PEMDAS.
Which is
Okay, guys, just so you know, there's nothing inside the parentheses except a number. If we do the parentheses first, that means we have to solve what's inside the parentheses, which is already negative.
Then it'd be x.
That is solved. Okay. So after the parentheses are done, which it's already done, what comes next?
exponent.
Exponents.
And then
We cannot multiply the 4 times the -2. That is not allowed. That is not what this expression is saying to do. This expression is requiring us to square the -2 first. Exponents come before multiplication. So we square the -2, which would be what? 4.
positive.
Then we multiply times 4. So what is it?
16.
Negative 16.
No.
Wait, but
Half your table is wrong. Also, you wrote your
No, a negative is negative.
your outputs for x and your inputs for
So
f of x are just wrong. Okay. Do you see how you wrote the function of x? But those are your inputs. So they should be squared. Okay. Also, those are wrong. All right, let's keep going, please. Now, I'm going to keep putting in my inputs. Okay? Yeah,
It would be 4.
very good. -1 times itself is +1, times 4 is 4.
Then
Also figure that they're not negatives.
Go ahead.
the next one is 0.
Yep.
Yeah.
negative.
Wait, why'd you put it inverse?
I don't know.
Wait, it's positive 8.
Wait, what?
16.
0 times anything is 0.
I think what we're doing is
Not doing
not following along, and then when you realize you weren't paying attention, you're like, wait, I can't because this is a do now. I am like more than halfway into the class period and I haven't even started the lesson for today. So what we have to do is follow along. Anybody who was paying attention, can you tell me, did I go through step by step how this gets solved, or did I rush through it?
Yes.
I would.
And I'm just asking why the parentheses in the 4.
No, I wasn't responding to you. I was responding to her. She's saying that the way I just wrote it like that for.
Oh,
There.
yeah, because I know
It doesn't matter. I wrote it like that. It literally did not matter at all.
Then with
Putting the parentheses on the 4 is totally fine. If that confuses you guys, I will switch it up. It doesn't matter what the parentheses goes around. So okay, then we have 4 times 1 squared.
Which is just 4.
4, and then 4 times 2 squared, which is 16. Okay. Do you notice anything, any pattern about our our outputs?
Parallel to the
Parallel?
like
You're
16
seeing,
and 4.
what does it start with an S?
Symmetrical.
Symmetry. We're seeing some symmetry, right? Where is the turning point?
0, 0.
0, 0. We call that turning point the.
Origin.
No, the old one. The
We call that turning point.
Wait, I got the inner.
It is where the axis of symmetry is, but we call that turning point the vertex.
vertex.
Yes, this 0, 0 coordinate, because it is the turning point from where, look, if we start here and we're moving towards the turning point, is the function increasing or decreasing?
Decreasing.
It's decreasing.
But then it increases.
And then it has a turning point and it increases. Okay? So from here to here it's decreasing, from here to here and beyond it's increasing. Let me go ahead and draw that over here. Let me draw that over here so we can actually see what it looks like when the function is increasing or decreasing. Okay, so I'm going to grab my coordinate pairs, and I have, negative 2, 16. That's going to be hard to graph. I'm just going to go ahead and graph my, my 3 pairs here. Negative 1, 4, negative 1, positive 4, 0, 0, and we have 1, 4. This is an extremely narrow parabola. Why is it so narrow?
Because why not?
Because the number, well, the A
Yeah.
is larger than 1.
You're a little genius over there. She didn't just say because the number is bigger than 1. She said the A. And I am just impressed.
Yes,
Because she
ma'am.
remembered that this leading coefficient is called A, right? So it is going to create a very narrow, that's why it's like jumping to such big numbers, because we're going to multiply
Nothing
things
to-
by 4.
Yeah.
So this parabola is going to be super
It's okay.
narrow,
It's okay.
that I can't even graph my other points on my little tiny coordinate plane. I know that looks really weird, it's hard to draw, but it is a curve. It's just so narrow that it actually kind of looks like a V, but it is still a curvy
And since,
U shape.
and since it's positive, doesn't it go above, like, the X line?
What?
0, 0.
Since it's positive, it goes above the X line, right?
Oh, since A is positive, it's a happy parabola. Yes, it opens upward. It's a happy parabola. We can make it nice and happy. There we go. He's super happy.
That was like
Yes.
$1.
Jim.
So that's the kind of comment that takes away from learning time. You're not the only one who does it, but since you said it, I was just going to point it out. Can we not? Because if anybody's going to be telling the silly jokes around here, it's me, because I do them while I'm teaching. Okay? So the question is asking, now that we can see our values of the function, the outputs, we can see what it looks like. Now let's answer the question, over what interval is it increasing? Well, let's see the portion, the space, where it's increasing. Is it always is this function always increasing?
No.
No. It's a parabola. It's going down, then it stops at the turning point and changes direction. It goes up. So describe to me where it's increasing. Describe it in any words you want. Yeah.
Y is greater than.
No.
Oh.
Yes.
At the top of the second pyramid.
Are you talking about a quadrant?
Yeah.
Okay.
Quadrant and goes down to the origin and goes up.
So, okay, all right. I hear what you're saying, but answer this question that I asked. Where is it increasing? We're only talking about increasing. Yeah.
In the first one.
So, yes, you're right. That's a good way to say it. Let's narrow that down because what we want to name is the values of x. We want to name the values of x because when we talk about the behavior of the function increasing and decreasing, going up and down, increasing and decreasing is talking about the output. So we want to know over what intervals of x. Yeah. Not quite, but you're on the right track, yeah. What's so funny over there? Nothing? Okay, so just, it took away from learning time though. Sorry, go ahead. It would be x is greater than 0. Very good. If you were to just like verbalize that in a different way, you might say, well, when the x values are positive, right? When the x values are positive, it's increasing. And we always read a graph from left to right. So when the x values are positive, as they continue getting more positive, the function is increasing. The mathematical way to write that is with an inequality. It's increasing when x is greater than 0. So this is the interval which continues on and on forever to positive infinity. Now, over what interval is it decreasing? Keep in mind that we're always reading from left to right. So if it's decreasing
X is
on this
less-
side, x is
less than 0.
less than 0.
I go to the front office.
Yeah. Does everybody understand? Okay, we're going to move on. I have about 15 minutes to teach today's lesson. I need 2 days. Now I have 15 minutes. I really need you guys to not mess around because this class really, really struggles with staying on task. Oops. Okay, so I'm gonna go to this one. Oops. Hold up. If you want to put the title, that's what it looks like. Quadratic functions in vertex form. Quadratic functions in vertex form. This is 7.2. Did you write this down? I'm waiting for everybody to write down the title. That's why I was standing here, just waiting, okay? Okay. So I kind of changed up these slides a little bit. I felt like when the book asks the question and then graphs it for you on the same slide, it's really, so I would love it. I know you guys like to follow along, but I'd love for you to close your Chromebook because I don't actually want you to see the graph, okay? I designed these slides specifically so that you can't see them. I don't always do that, but I think it was too much information when they do it for you while they're asking the question. Now, this says, understanding the graph of g of x equals x squared plus k. What the heck does that mean? What's k? Why is it there? It just, only if I ask questions or if you really have a question that's gonna help move things along, okay? So, I'm not gonna worry about what k means right now. All I'm gonna tell you is that it is going to be part of what we call vertex form, which will be revealed to you at the end. It's part of vertex form. We're going to show a function that does something similar to what you see here. Now, you know what do we call this function?
Parent function.
Parent function, very good. The parent function is the simplest quadratic function you can have, or the quadratic parent function is the simplest quadratic function you can have. But what happens to parents at some point? No, this is more.
They leave their children.
They get
What
mad.
happens to parents?
They get child.
Well, I should probably say like this. What makes a parent a parent?
Oh,
Great
they
child.
They have a little baby.
That's me!
Yeah.
My baby right here.
I'm a baby.
Would I be able to say, would it be okay if I say silly things like that and you guys have a 5-second giggle and then we continue learning? Instead of start commenting and turning to each other. Would that be okay? Or do you want me to not say silly things and just teach like this? It's up to you guys. What would you like? Silly things? Good answer. But if I say silly things, we still have to be able to pay attention and continue learning. So the parents are gonna have a little baby. And this little baby kinda looks like mommy and daddy. Kind of.
Uh-oh.
What about the baby? No.
Wow, that mom is
So now we're not learning anymore, okay? Yeah. So what I'm trying to say is, I didn't mean it to sound like that. What I was implying was, when mommy and daddy have a baby, the baby has some features of the mommy and daddy, right? Like, oh, you've got your mommy's eyes and your daddy's nose. But But the baby also kind of looks like himself or herself. They have some things that are not totally
Unique.
like their parents, right? So this little baby, we're gonna name him
Greg.
Timmy.
Junior. G for Junior. Okay.
That's Junior.
Here's the parent function. Here's little Junior. Okay, get it? G of X. I spelled junior with a G. Yeah. Okay. And now, what is similar about Junior and his parents?
X.
Not just X, but
The F of X, but it's
Nope.
like
He has a parent function, except they just switched up the F for the G.
okay. That's just his name. Yeah. That's like mommy and daddy named the baby Junior because he can't have the same name. Yeah.
Squared.
The X squared. Thank you. The X squared is what Junior got from his mommy and daddy. Okay? But Junior also subtracts 4. So that's what makes him a little bit different. This question asks, how does the graph of Junior compare to mommy and daddy graph? Okay? First, let's graph mommy and daddy. Let's remind ourselves what the parent function looks like.
Are we gonna add on another section?
So we have -2, -1, 0, 1, 2. You probably already have this written down. You don't have to do it again. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So we have our parent function, which is -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. This is the parent function. Mommy and daddy are so happy because they're having a little baby. Now, this little baby looks a little bit different on the graph. How? Let's see. Let's put some inputs into this function and see what the little baby looks like. Junior. Let's use our same inputs.
Oh, I'm a genius.
And no. Okay, so let's see what little Junior, are you okay? Let's see what little Junior looks like. So -2 is gonna be squared, and then we're gonna subtract 4. Hey, you know what?
0.
Notice that this first part that we have to complete, isn't that the exact same thing as the outputs? So can't I just, instead of writing all of that, can't I just write my outputs here? My outputs of my parent function.
Yeah.
4, 1, 0, 1, 4.
And
And then just subtract 4, right? That'll be much easier.
oh, it's a frowny face.
Is it?
Yeah.
No,
Where'd you
it's not.
get those
But yeah, it is.
These?
It's a fountain face.
It's a
So
frowny face.
instead of putting -2 in parentheses squared, -1 in parentheses squared, the X squared is
yeah, I
the
see.
same thing as parent function, so I just use those outputs. So now we're subtracting. 1 minus 4 is -3, 0 minus 4 is -4, 1 minus 4 is -3, and 4 minus 4 is 0. Ooh,
Even.
where's the turning point on this
That's a
graph?
negative
No.
4.
Where's the turning point, Grayson? Nope.
Wouldn't it be in
Oh.
between?
Wait,
Negative 4. Negative 4 is 0.
yeah.
There is no.
It's 0, -4, there is a turning point. What we see with our outputs is
Oh.
the symmetry 0, -3, -4, -3, 0. This is the spot that
The vertex.
separates those symmetrical numbers, those symmetrical outputs. So this, the 0, -4, is the vertex. You guys see that?
Yeah.
So 0, -4, 1, 2, 3, 4 is our vertex. And then our other points are -2, 0, -1, -3, 1, -3, and 2, 0. Oh, no different than mommy and daddy? Faith,
His face is in the middle.
his face is in the middle. Okay.
He's lower on the graph.
He's lower on the graph.
He's short.
Very good.
Yes.
What's in my hair?
He's lower on the graph. How could we kind of describe that mathematically?
Wait,
Wait,
He has a negative y-intercept, but yeah.
f of x that equals x squared is greater than,
No, I don't want you guys to think too deep mathematically. We'll just say it's lower. How do we say lower? What happens from the mommy and daddy? What happened to go lower?
The decrease and his negative.
Yeah, we call it a shift.
Oh.
When the graph moves downward, it shifts downward. So we would say that the graph of G of x, shifts 4 units downward. Lily, did you get all this? No? None of it? Okay. So it shifts downward. Can somebody tell me what you notice? How many units does it shift down?
4.
4. Where do you think that information is in the function?
oh,
It's right there.
it's right there.
It's right.
It's the one where it like separates from the parent.
Where the y-intercept is.
Yep. It shifts down 4 units. So you want to see something cool? We can answer these questions without doing tables or
What?
drawing the graphs. Answer this. How does the graph of this function differ or compare to the parent function?
It goes up by 3.
It shifts up
Oh my god.
3.
And then the next
3
one
units.
shifts down by 2.
How easy is that?
Yes, sir.
Okay. So the K tells us where or how many units it shifts upward or downward. K tells us how many units it shifts vertically.
God bless you. God
Bless
bless
your
you.
heart.
If K is positive, it shifts upward. If K is negative, it shifts
Downward.
downward, which is very self-explanatory, easy to remember. A positive K
Has a
will shift
positive attitude.
upward towards positive infinity. A negative K will shift downward. Nice and simple, right?
Yes. This is easy.
Yes, that was easy.
But,
I
however,
can't.
So dumb.
Jinxed it.
Yep.
She's about to call it the most confusing college level equation ever.
So the next one that I'm gonna show you is as simple, but it's kind of like a backwards thing in your head. And we have already encountered this type of shift and that type of shift when we did absolute value functions. Absolute value functions and parabolas, they're so similar, right? One's a U and one's a V, but they're both, they both open upward or downward. Okay, so let me show you this. How does the graph of, okay, so now the number isn't being subtracted from the output of the parent function, it's not being subtracted from x squared, it's being taken away from x, and then it's being squared. So we would consider that we're taking away from the input here. We're taking away from the input. So let's go ahead and do a table of values. I'm gonna do this so quickly, I'm very sorry if it's going too fast for you, but it's either I teach it or I don't. So let's see, if I need x minus 3 squared, and I need my output, okay, so then I do 2 minus 3, I'm sorry, negative 2 minus 3, and then I square that. I'm going to kill the cockroach and change the sign. I've got negative 2 plus negative 3 is what?
One.
-5.
Negative 5 squared is 25. I'm just gonna have to go. I'm sorry if I need you guys to shout out the answers, but if you can't, I'm gonna have to keep going. Okay, plug in a -1 minus 3 squared. Kill the cockroach, change the sign. We get -4 squared is
-16.
positive 16.
Oh yeah, because you multiply.
Right. 0 minus 3 squared is
Zero.
So negative.
-3 squared is
-6.
positive 9. 1 minus 3
16.
is -2 squared is
64.
4.
What's it 16?
Doesn't matter, right? 2 minus 3 squared, -1 squared is 1. Does anybody see the turning point yet?
There's
No.
It's just a line.
There is, we just haven't reached it yet because, we'll see in a second. I'm actually gonna keep plugging in some values. They're gonna get easier from here on out. 3 minus 3 is 0, squared is 0.
So that's the turning point.
4, we don't know if it's the turning point until we see symmetry. Just because it's a 0 doesn't mean it's a turning point. Although it might be, I'm just saying it doesn't have to be. So 4 minus 3 is 1, squared is 1.
Oh my god.
5 minus 3 is 2, squared is 4. Do we see the turning point? So the turning point is 3, 0, that's our vertex. Now since I don't want to graph 25 and 16 over here, I'm going to put this little baby, I'm just going to graph around my turning point, my vertex. So I have 3, 0, 1, 2, 3, 0. Oh my gosh, look where that vertex is. And then I'm going to do 2, 1, 2, 1, 1, 4, 1, 4. Nobody pack up, nobody's leaving. I still have a few minutes. 4, 1, and 5, 4. And the little baby is 1. That's right. Yay! The little baby is born. How does this little baby compare to mommy and daddy?
It shifted to the right.
Yes, it shifts to the right. How many units?
3.
3.
Tree.
Look at the function. Oh, what's weird about that?
It's shifted.
It's negative, but it shifted to the right.
Because
So the good news is the number sticks, right? The number is how many units it shifts, but the sign actually shifts to the opposite of what the sign tells you to do. Then a subtraction will shift to the right. Addition will shift to the left. So the vertical shifts go exactly with what the sign says. The horizontal shifts go in the opposite direction that the sign says. Do you guys understand that?
Yes.
Okay, one more thing I want to show you.
So positive would go that way.
Yes. One more thing I want to show you really quick. Write this down. This is vertex form. It does not need to be memorized. It's on your EOC reference sheet, but write it down and then write vertex form. This is all I want you to take away from this. H and K, when you put them together, like an X and Y coordinate, that's your vertex. So when you see a quadratic function in vertex form, it's automatically giving you your vertex. But here's the tricky part.
You gotta find the.
The H coordinate will be the opposite sign of what it says. So look at this function, for example. This H is a -1. So what will the H be of your vertex? Positive 1. Now the K is going to stay the same. Now here's how we're going to remember it. The H stands for get that sign the heck out of here. H for heck. K is for keep. Okay, so when you're pulling your vertex from vertex form, whatever your H and your K are, you get that sign the heck out of there, and K you keep. Get that sign the heck out of there, switch it to the other sign, and K you keep. Does that make sense?
Yeah.
You guys can go.